So this is my code for quiz 3, which was the elevator. This one took a while, a lot longer than I was able to do during the lab time. So here we are. So you start out, normally you have the library and the packages. I don't think I used either of these two, so I'm pretty sure you could take them out, but I didn't because I didn't feel like it. Here we declare the entity, and then we do all the ports, and then you have, I just did all the ones that were on the example waveform that we were shown. So we have all these as normal standard logic inputs, and then here we have two vector outputs to show what floor you're on and what the count for the door is at. Then here you have up, down, door open, door closed, just to show you kind of what's going on in it. And that was also just on the waveform, so I put it there. I had others that I used as I debugged, but I got rid of them because they don't really show you anything other than the logic that's happening inside, and that's all it's really useful for. So then we end the entity and we get to the architecture. So this is where a lot of the fun happens. So I made floors, I made them a state just because that was how I imagined it working. And then I made the doors kind of like a state, but they don't have their own case. They happen inside the case of the floors. So they kind of work like it, but not really. It just made the logic a lot easier to do. And then here I just pretty much, I gave almost all of the inputs and outputs that you see here their own signal. That way they're easier to work with, and I don't have to worry about, these are inputs so I can't change them. So yeah, and then I initialized all the values to whatever I wanted to start with. So I started on floor 1, you could start on whatever floor you want. And I started with all the doors open. You could start with it closed and then hit the button to open it, but this just made it simpler for me. So here you can see the state definitions that I made, and that's just the states for the floor. I didn't make the state for the door because it's not really a state. It just kind of is. It's a counter. So here you can see the process. The very first one is based on the clock 1 and clock 2. And here you can see that on the rising edge of clock 1, the state is going to transition into the next state because the floors were based on the slower clock. And then you can see here is where you kind of have the doors, but it's not really a state. I just make it change to whatever the next door is on clock 2. And so end that process. It's a short one, but it's because there's a lot for the next one. This is where it gets very complicated. So I have it based on all of these, and you'll kind of see why as we go. To start with, I make it everything's happening on the rising edge of the clock. That way, you don't have any errors when you try and compile it, and one thing's not based on the rising edge. Yeah. So right here we have our first major if statement. It just pretty much, whenever you press a button, that pulse is only going to last so long in real life, but here I just extend each of the signals. So I give them each their own technical signal, and it's a 1 until later on it'll become 0 when I state that it is. So this goes away very quickly. This stays 1 until we get to that floor pretty much. And here you can see the cases for all the states. And I'm just going to go over 3 of the major ones because a lot of the ones in the middle are the same. So when it's at the basement, you can't go any. Yeah, I'll get to the logic for the next floor. I'll do the logic for door opening now because door opening is the same for all of them. That was pretty much just a copy paste once I got it right. So first you have if the extended signal is high, and you didn't have to do that technically for the bottom one, but it just made it easier to copy and paste to the others. So if the extended signal is high, then that means you're on the correct floor. So we can start with opening the doors. So you start counting down, next door is 3. And then I make sure to set up, down to 0. I make sure to set that extended signal to 0 too. And then I have these dummy variables. I call them dummy door variable. It's like 0 to 3 pretty much. I tried to use just one of them and it wouldn't work for whatever reason, so that's why you see 3 of them. It would only work when I made 4 separate ones. So yeah, that'll happen on the first clock, and then the next clock it'll see that this dummy door variable is high and door is at 3. So this will happen. You get the next door goes to 2, and I set the one from before to 0 and a new one to 1, so that it'll only happen in this case. And then you go to the next door at 1, same thing, just with one new variable and the other is set to 0. And then at 1 you get the same thing as you saw before and it goes to 0. And here at 0 you can finally do something interesting. You can close the door, or you can set close to 0 and you can open the door finally after those were gone through. And so that's the logic for door opening, and it happens the same exact for every single one of these. So I'm just going to go over it just this one time. The logic for the level is a bit more interesting. So I just said if, in this case, it was if it's 1, 2, 3, 4, 5, 6, or 7 goes high. So if any of the ones besides from 0 goes high, then we're going to start with the process of closing the door so you can start moving up in this case. So I use another dummy variable for this one just so it's easier to make all these if statements. And yeah, so then you start the countdown for the door, and then you keep going with the door countdown until you get to when the door is at 0. Now you can close the door here and open goes to low. And now we can see that the next state is just going to be the floor above it, which is 1. And here I make the signal, up signal 1. And the dummy variable goes to 0 there, but that's not important. The important thing is this up signal 1, because you'll see that in the next one. So you have the same, if you're trying to go to floor 1, it'll open up. And if not, we go here. So if the up signal is high and the 1 signal is low, that means you weren't trying to go to floor 1. So you don't need to go through the process of opening and closing the doors. Instead, you can just say the next state is immediately 2. And that skips the whole process of opening and then closing the doors again. Also, if you're going down and it wasn't supposed to be 1, then you can do the same thing, but go down to the basement without opening and closing doors. And then if you were on floor 1, these will happen. So if you're on floor 1 and the 0 gets pressed, then you're gonna start the countdown for the door, but you'll be going down. That's what the down variable is for. If you pressed any of the ones above 1, then the down countdown will start, but the up variable is used here. And you can see here is where you see the up variable. So the next state will be 2. And if the down variable is high, then the next state was 0. And yeah. And then all the middle ones are the exact same logic as floor 1, except for 7, where it's kind of like the inverse of 0. So you have the same logic for opening the door, but here you have, if any of the floors below 7 are pressed, then you're going to go down because you can't go any higher than floor 7. It doesn't loop back around. And so you have, you're going to go down. You can see we use the down variable, and then we do our countdown until we get to door 0. And so on door 0, now that the down variable is high, we can set the next floor to 6. And we also put the doors closed, and the open door, it goes low. we set our dummy variable to 0, and our down signal goes high just in case you were trying to go to the 5th floor. You won't have to stop at floor 6. And so yeah, it took quite a while to do this, but yeah. So now let's see, let's open our waveform so I can show you what's happening there. Run that really quick. Okay, so here you can see we get the pulse for floor 7. So that's not going to stick around. It ends right here, but not shown here is our 7 signal will extend out, and that's what allows us to do all this. So we start on floor 0, as you see here, and the door close, you can see right here in line with this clock edge, because it's based on clock 2, it starts the countdown down. And because I had to do the whole thing of the processes, it's gonna last here and then there. So it'll last, I think, 2 cycles. Yeah, I'd call that 2 cycles there. And then once it gets back to 0, you can see on this clock cycle, you get the up signal. So now it's going to start going up, and because it's going to start going up, you have to close the doors. So it goes to floor 2, 3, 4, 5, 6. Doesn't have to stop at any of them because that's not its destination. Its destination is 7, which is right here. So once we get to 7, you can see that the up, it goes low, and the door close countdown starts here, and now the doors are open. But you can see as that happened, we got another signal to go to floor 3. So the countdown starts again, and once we get to 0, the doors will close, as you can see here, and you're going to start going down. So you start going down 6, 5, 4, and then you get to floor 3. Floor 3, you can see that the down signal goes low, and then you get the door countdown again, and then once it gets to 0, the doors open, and yeah. So that was this.